go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, today we're going to be reviewing for the Chapter 9 test, which is tomorrow. Just a reminder, tomorrow there will be no class meeting. I will be here at 1:15 tomorrow afternoon, and I'll be here today at 1:15 for office hours, but tomorrow no class meeting. You just take your Chapter 9 test, no later than finishing it at 11:59 tomorrow evening. All right, I have some questions that I'm going to look at now. This is, let's see here, this is from section 9.5, number 10. It says, solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. So an extraneous solution is one that we get in the process of solving the equation, but when we check it and plug it back in, it doesn't work. Okay, so our equation is this. 1 equals 2 plus the square root of the quantity 4x plus 50. So the first thing I'm going to do is isolate the radical. I'll do that by subtracting 2 from both sides of the equation. This gives me -1 equals the square root of 4x plus 50. I can already tell you that there's going to be no solutions. Any solutions we get are extraneous because a radical cannot equal, or I should say an even-rooted radical, square root in this case, cannot equal a negative number. That was one of our 3 big rules. But anyway, let's continue. So we're going to square both sides. On the left side, we'll get 1. On the right side, we'll get 4x plus 50. Then I will subtract 50 from both sides of the equation. -49 equals 4x. Divide both sides by 4, and we get x equals -49/4. I'm going to go ahead and convert that to a decimal because the person that asked about it also did that. Let's see, -49 divided by 4 comes out to -12.25. All right, now I'm going to take that solution and either this one or that one. I'm going to go ahead and use the fraction and plug it back into the original equation to see if it works. So now I get 1 equals 2 plus the square root of 4 times the quantity, -49/4 plus 50. 1 equals 2 plus, I keep wanting to write plus or minus, and that's something coming up later. Sorry about that. Plus the square root of, let's see, 4 times -49/4 would reduce down to -49. -49 plus 50 would reduce down to 1. The square root of 1 is 1, so we get 1 equals 3. So that means that this solution is extraneous, meaning it doesn't fit the original problem. Okay, any questions on that before we go on? Let's take a look at problem number 12 from that same section. So this again is 9.5, number 12. It says solve the equation. We have the square root of 6 minus 2x equals 8 times the square root of x minus 3. We have 2 radical terms. They are already separated, one on each side of the equal sign. That's good. So now we're going to square both sides since the index is a 2 in each case. So we're going to square that and we're going to square that. On the left side, we get 6 minus 2x. On the right side, we get 8 squared and then x minus 3, because this 2 outside applies to both the 8 and the square root of x minus 3. So then we get 6 minus 2x equals 64 times x minus 3. 6 minus 2x equals 64x minus, let's see, 192. Is that right? 180, 12? Yeah. Let's see. I'll subtract 64x from both sides of the equation. Negative 66x plus 6 equals negative 192. Subtract 6 from both sides. Negative 66x equals negative 198. Divide both sides by negative 66. And let's see, I think that comes out to x equals 3. And let's check that to see if that works. If x is 3, we get the square root of the quantity 6 minus 2 times 3 equals 8 times the square root of the quantity 3 minus 3. On the left side, we get the square root of 6 minus 6, which is the square root of 0, which is 0. On the right side, we get 8 times the square root of 0, which is 8 times 0, which is 0. So x equals 3 is a correct solution. It checks. Any questions on that before we go on? Okay, now we're going to look at a chapter review question. Let's see here. Number 8. Okay, so this is the chapter review. That's chapter 9 review. Number 8. It says, find the domain of the function. Enter your answer using interval notation. All right, and the function is g of x equals the square root of x plus 16. Now, since the index is a 2, that is to say we're taking a square root or second root, that means that the radicand, the stuff inside the radical, has to be non-negative. That means that x plus 16 has to be greater than or equal to 0. Okay, now solving that inequality, subtracting 16 from both sides, we get that. So the domain in interval notation would be negative 16 up to infinity, with brackets around negative 16 and parenthesis around infinity. And there we have that one. Any questions about that problem? All right. Well, those are all the questions that were emailed to me. Do any of you have any questions right now you'd like to explore?
Actually, can you find the range for that question?
The range. Okay, sure. Let's see here. Probably, well, yeah, we can do that quite easily. Consider this, okay? When we're taking an even root of a radical, there's two things we have to be careful of. First of all, we can't take the square root of a negative number, so that's where we get the restriction on the domain. Secondly, the answer, the result, can't be negative. So that means that our range can't have any negative values in this case. Then the question is, could the range be 0? Well, if x is negative 16 plus 16 is 0, the square root of 0 is 0. So the range could be 0. Then as we put in positive values, the range could get larger or larger. So the range in this case would be 0 to infinity. Does that make sense?
Yes.
And graphing it would maybe help to see that, but if you want me to, I will, but otherwise we'll just go on from there.
No, it's okay.
All right. Any other questions you'd like to explore at this point? This is all we're doing today, is just reviewing, answering questions you have to get ready for the test tomorrow.
On the chapter review, can we look over question number 17?
Sure. Okay. And let me pull up yours. Let's see. Chapter 9 review. You said number 17. Okay.
Yes.
All right. I want to look at, let's see here. It says, so this is chapter review, chapter 9 review, number 17. It says, simplify the expression, and the expression is negative 125 over 27, all to the negative 4/3 power. Okay. So the first thing I'm going to do, I'm going to, let's see, I'm going to take the reciprocal of what's inside, which will then change the sign of the exponent from negative 4/3 to positive 4/3. Are we okay with that move?
Yes, I see what you did there.
Okay. Next, I'm gonna apply the negative sign. This one right here, I'm going to move it up and just have it apply to just the numerator instead of the whole thing or just the denominator. So then I'm going to apply the 4/3 exponent to the numerator and the 4/3 exponent to the denominator. So if we have a quotient raised to a power, we attach the power to both the numerator and denominator of the quotient. Are you okay with that?
Yeah.
All right. Next, I'm going to rewrite this, and I'm going to do the root first and then the power. I'm going to rewrite this, and I'm going to do the root first and then the power. Are you okay with where I got the 1/3? So 4/3 is 1/3 times 4.
Yeah, I see what you did there.
Okay. So what is the cube root of negative 27?
It should be -3.
Okay. And that's going to get raised to the 4th power. What is the cube root of 125?
It's 5, right?
Okay, and that's going to get raised to the 4th power. Now, -3 times -3 times -3 times -3 is positive 81. 5 times 5 times 5 times 5 is positive 625. And this answer won't reduce because the factors at the top are 3s and the factors at the bottom are 5s, and that doesn't reduce. So your final answer would be 81 over 625.
Yeah, I tried doing this problem before, but somehow I switched the numbers. So I got the same answer, but they were just switched.
So you got 625 over 81.
Yeah.
I wonder, did you do this? Did you take this negative and that negative and sort of make them cancel each other out?
Yeah, because
Okay, yeah. And you
I
got to be
don't
careful
know
because,
how.
I'm sorry, what was that?
I said I don't know how I flipped them. I think I watched the video and I thought I was doing it right, but I guess I wasn't.
Okay, so when you flip it, the negative sign still applies, but this becomes a positive exponent. So flipping it just gets rid of the negative sign on the exponent. It doesn't get rid of the negative sign inside. Okay.
Okay, well, thank you.
You're welcome. All right. Anything else, folks? Well, if you don't have any other questions, then we'll close the meeting and I'll be back at 1:15 if you come up with anything else. Other than that, have a great day, and hopefully it won't snow tonight. Who knows? All right. Take care.
Thank you.
Actually,
thank you.
I had another question on the review. Sorry.
Okay. You're one of those people that likes to wait till the last second. Wait. Okay. What do you got?
Yeah, sorry. I was trying to look for it in the review and I couldn't find it.
Okay.
Okay, so it's question number 22
22.
on the review.
Okay. All right. So this is number 22 on the review. We've got the 4th root of 162 x to the 12th y to the fourth. The directions say simplify the radical expression. Then it says all variables represent positive real numbers. So because of that, we do not need or want to use absolute value bars, okay? Okay, because it said all the variables are positive. Now, 162 is 2 times 81, which is 2 times 9 times 9, which is 2 times 3 times 3 times 3 times 3, which is 2 times 3 to the fourth power. Okay, I'm going to rewrite the original radical as the fourth root of 2 times 3 to the fourth times x to the 12th times y to the fourth. Okay, now we're going to go across and simplify each factor inside. The fourth root of 2 isn't going anywhere, so that's going to stay inside. The fourth root of 3 to the fourth would be a 3 on the outside. You okay with that? All right.
Yeah, I'm okay with that. I see.
The fourth root of 12, excuse me, the fourth root of x to the 12th would be x to the third. 12 divided by 4 is 3. The fourth root of y to the fourth would be y on the outside. So what's left inside? The fourth root of 2. So my final answer is 3x cubed y times the fourth root of 2. And again, no absolute value bars.
See, I got the same answer, but I don't understand why you put the variables on the outside of the square root.
Okay, if I've got the fourth root of x to the 12th, that's like x to the 12 fourths or x to the third, right?
Yeah.
But I used up this. So this becomes x cubed, but it's outside of the radical because I already used the fourth root to get it to there.
Oh, okay. Now I understand.
Yeah, and I see what answer you've got. So you had all the right numbers, but they were still inside and you had absolute value bars. So when you use a root to kick something outside, it goes outside. So like, for instance, the cube root of 8 is not equal to the cube root of 2. It's equal to just 2 because you've used up that cube root in the process. Okay.
Okay, well, thank you.
Yeah. Anything else, folks? Now is the time. Don't wait.
Can you do another question like that?
Absolutely. So just like the one we had here, like number 22, but a different version.
Yeah.
Okay. Let's see here. How about, let's see, we'll go the sixth root of, hang on a second here. Let's see, come up with something. Ooh, wow. Yeah, that'll work. The sixth root of 2,187, x to the 18th, y to the 8th. This one's actually a little more difficult. It's the same idea, but so what I've got to do is I've got to look at the 2,187 and figure out, is that something to the sixth power with some stuff left over? Okay. Do you remember how to figure out what factors are involved in a number? For instance, if a number's even, 2 goes into that number. If a number ends in 5 or 0, 5 goes into that number. How do you tell if 3 goes into a number? You add up all the digits. So in this case, 2 plus 1 is 3, plus 8 is 11, plus 7 is 18. If 3 goes into the sum of the digits, 3 goes into the number. 3 does go into 2187. How many times? Well, let's see. We'll take 2187 divided by 3. We get 729. If I take 729 divided by 3, I get 3 times 243. 243 divided by 3 is 81. 81 divided by 3 is 27. 27 divided by 3 is 9. So we get 3 to the 7th power. Any questions about what I just did there?
No.
Okay, so here's what I'm going to do. I'm going to rewrite my radical. And instead of 3 to the 7th power, I'm going to write 3 to the 6th power times 3. Why? Because I want my exponents to match the index or be multiples of the index. Okay, so 3 to the 6th power, the 6's match, 3 to the 1 power is left over. X to the 18th power, 18 is a multiple of 6, so I'm going to leave that alone. Y to the 8th power, I'm going to write it as y to the 6th times y squared, because the biggest multiple of 6 I can take out of there is just 1, so a 6 with 2 left over. You see what I'm doing there?
Yeah.
Okay, so now the 6th root of 3 to the 6th power is 3 outside. The 6th root of plain old 3 is stuck inside. The 6th root of x to the 18th power is x cubed, outside. The 6th root of y to the 6th power is y, outside. The 6th root of y squared is stuck inside. So I've got 3x cubed y times the 6th root of 3y squared. Any questions about that?
No, I think I got it.
Okay. Anything else? Other examples? Something else?
So do you only use the absolute value when it can be either a negative or a positive?
Okay. You use the absolute value if, first of all, it tells you the variables are unrestricted, so they could be
Okay.
positive or negative. Then you would only use it if you're taking an even root.
Okay.
And then you would only use it if the answer could be negative. For instance, if you've got an answer of x squared, that couldn't be negative anyway.
Yeah.
Yeah. So there's a lot of conditions there.
Okay.
Can we try problem number 28 on the review, please?
Okay. This says, simplify by combining like radicals. And I have the square root of 125 plus the square root of 45 minus the square root of 180. Okay. Now, simplify by combining like radicals. So what we need to do first of all is go through and simplify each separate radical as much as we can. We're taking square roots all the way across. So I want to take 125 and break it down into square roots and leftovers. So I'm going to rewrite 125 as y, or as 5 cubed, but rather as 5 squared times 5. The square root of 5 squared is 5 on the outside, and I have 5 inside the radical. You okay with that?
Yeah.
All right. Next, we've got 45, which is 9 times 5, or 3 squared times 5. So plus 3 squared times 5, but the square root of 3 squared is 3 on the outside, and that's what? Plus 3 square roots of 5. And finally, let's see, 180, that would be, let's see, 2 times 90, 2 times 9 times 10, 2 times 9 times 2 times 5. I've got 2 squared, 3 squared, 3. Okay. So 2 squared, 3 squared times 3 minus the square root of 2 squared is 2 outside. The square root of 3 squared is 3 outside. So I've got 5 square roots of 5 plus 3 square roots of 5 minus 6, that is the 2 times 3, times the square root of, is that right? 3. No, it's not right. I made a mistake. My bad. Right here, that should have been a 5. Can't read my own writing. I was suspicious because it didn't match the other ones. They don't always do that, but you okay with that? So right here, this is a 5. Nah.
Yeah, I was gonna say something when I saw the square root was under 3. I thought they were all under 5. I thought I did something wrong.
No, feel free to jump in and say, hey, I think you're wrong. It won't hurt my feelings. I'll just cry in the
Okay.
corner all day. But I do that anyway, so it's no big deal. That corner's gotten awfully wet. Okay, now these are all like radicals. So 5 of this plus 3 of this is 8 of this. 8 minus 6 of this is 2 of this. This being the square root of 5. Okay,
Okay, thank you.
you're welcome. Something else.
Can we do number 17 on 9.5?
Okay, hang on. Let's see. Sarah, that was you, right?
Yes.
Okay. 17. Just want to pull up your specific problem. And okay. All right. So this is 9.5, number 17. It says solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. All right. It says let h of a equal the 4th root of the quantity a plus 12 minus the 4th root of the quantity 2a plus 6. Find all values of a for which h of a equals 0. Now, they're not asking us to find h of 0. They're saying what values of a make h of a 0. So we're going to take this and substitute it right there. Okay. So now our equation becomes 0 equals the 4th root of a plus 12 minus the 4th root of 2a plus 6. I've got an equation with 2 radicals. I want to separate them. I'm going to add the second radical to both sides so that we get rid of that negative sign. So I'm going to add the 4th root of 2a plus 6, add the 4th root of 2a plus 6. So now I've got the 4th root of 2a plus 6 equals the 4th root of a plus 12. Okay. Now, to get rid of the radicals, I'm going to raise each side to the 4th power, which gives me 2a plus 6 equals a plus 12. Any questions so far before we go on?
No.
Okay. I'm going to subtract a from both sides. A plus 6 equals 12. Subtract 6 from both sides. A equals 6. And then I'm going to check that. So I'm going to check that here. Let's see. We'd have 0 equals the 4th root of 6 plus 12 minus the 4th root of 2 times 6 plus 6. 0 equals the 4th root of 18 minus the 4th root of 18. Well, wouldn't the 4th root of 18 be equal to the 4th root of 18? So these are going to cancel. 0 equals 0. So it says, so the answer would be 6, and it is not extraneous. It says if it's extraneous, so indicate. So you'd say not extraneous, and a equals 6. All righty. Anything
Okay.
else? Anybody? Anything?
Can we try problem number 30 on the review?
Okay. Here. Review. Number 30. Okay, so this is the chapter 9 review number 30. It says solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. We have the square root of 2x plus 9 equals 7. So the first thing I want to do is isolate the radical. I'm going to do that by subtracting 9 from both sides. I can already see a square root cannot equal a negative number. So any solution I get is going to be extraneous. It's not going to work. But let's go on and find it. So now I'm going to square both sides. So I get 2x equals 4. Let me write that a little better. I should have a negative 2 and then that whole thing is squared. So dividing by 2, I get x equals 2. But if I plug that into the equation, I get 2 times 2 plus 9, 7. Square root of 4 plus 9 is 7. 2 plus 9 is 7. 11 equals 7. No, it doesn't. So extraneous solution. So you'd say 2 is the answer you got, but it doesn't work. Okay.
Thank you.
What's next? Anybody? Are we done?
I don't have any more questions, but if anybody else does, I don't.
Now is the time. All right, well, I'll stop the recording and maybe I'll see you this afternoon. If not, hope you do well on your test tomorrow. Bye now.